In this video, we're going to look at how to interpret the output of a Pearson correlation coefficient in SPSS. So what we've done is we've looked for a relationship between a person's age when they started their employment and their total competency score before they started their job. Now both of these are continuous scale variables, and we checked already that they were normally distributed and that they had a linear relationship, which is why we used Pearson's R correlation. So you can see across the diagonal that they're both 1, and that's because if we correlate a variable with itself, so age with age, it will be perfectly positively correlated. And if we correlate total competency with itself, it will be perfectly positively correlated. Now, correlation coefficients are always between -1 and 1. And +1 means perfect positive, -1 means a perfect negative correlation. And that means they're exactly on a straight line. Now, these correlation coefficients here are both the same because they're the same correlation. So this one is age with total competency, and this one is total competency with age. So it's actually showing the same thing. The first value is our actual correlation coefficient, and this tells us the strength of the linear relationship between our variables. And we can see here 0.228. If we were to look on a table, we would see that this is kind of a small, almost moderate strength, positive correlation because this value is positive. And the second thing I want to look at is my significance value, which is 0.060. Now I compare this to my level of significance. The level of significance I've chosen is 0.05. You may have chosen 0.01, so use the significance level that you're using for your test. And if this is greater than my level of significance, it means that my correlation isn't statistically significant. It means that it just occurred by chance. Because remember, we're using statistics because we have a sample, not a population. So what I'm saying is that in my sample, I observed a small positive correlation, but there's not enough evidence to say that this correlation exists in the population. If my significance value had been less than my level of significance, so this is my p-value, if it was less than 0.05, then I would have been able to say that there's enough evidence to suggest that the correlation we observed does exist in the population. But because this is greater than, we have to say that there's not enough evidence to show the correlation is significant. If you want to see me work through an example with a significant result, just have a look at the correlation interpretation for Spearman's rho.